Very good morning to you all again. We are with the power system operational control subject. In line with that, we began our discussion in the previous class, the concept of preventive and emergency control for the appropriate operation of the power system. We have just interacted with these things. Five to six points which are listed over here. We have just interacted how they prevent the probable occurrences of disturbances, impacts of such a disturbance which is unavoidable to a reduced extent, like that. How preventive measures make the things possible was interacted in the interaction class yesterday. Again, when the system is so worse, we just took up interaction called emergency control. How these emergency controls definitely bring the system's state to a good and controllable state was interacted, having discussed some points like how tripping of generator make the generation decrease so that loads and other components are disconnected in steps, in parts, like that, so that such a massive impact, major disturbance which is causing a worry will be diminished by the control, like tripping of generator, taking out of the generator from the schedule to decrease the total net generation, load shedding, removing the load in part or in full as required, making the fast valving, diverting that, suppose it is an hydro turbine, diverting that water or fluid which is driving into the turbine blade into other direction, or making the reduction in the generation is possible. Then controlled disconnection of the system to prevent spreading of frequency problems. As we were very concerned about the frequency sensitive loads, when the frequency is changing, definitely the inductive and capacitive loads get affected by the change in frequency. Because of their impact, there will be a tremendous change on the requirement of active and reactive power on the power system. Hence, the frequency deviations, what would occur, it should be spreading of that should be prevented. Then controlling an islanded area. It means in an disconnection state, when emergency state is resulted, the wrong set point, wrong control definitely make disintegration of the setup, generation setup, a sub-transmission setup, a distribution center, like that. Naturally, they get disconnected like a natural disaster viewpoint if you view, and local generation, local balance, local transmission line, and disconnection of load, handling the situation in groups, in parts has to be worked out. That's what is the controlled landing to create local generation and load balance. You can just imagine a flood situation, locally the group of people, locality being addressed by the local support team and the particular agency, whatever kind of support which they can extend to the locality and to the next part, like that. Similarly, in electrical disaster or in the emergency situation connected to the power system, disconnection, islanding do deserve certain attention. And blocking of that figure of transformers. Naturally, when we have a disaster or drop in voltage due to any other reason, maybe fault, maybe lack of reactive power, definitely the transformer comes into picture to shift the working voltage by automatic tap changer concept. The tap changer is a facility connected to the power transformer and transformer at the side, which automatically sensing the terminal voltage shift the tap number so that such an delta V added to the terminal voltage boosts it to the required level of voltage. Like tap changers start hunting, they start adding more and more steps to the actual voltage to try for the best terminal voltage. In that due regard, tap changers start hunting too much and may fail, might cause damage to the interconnections, like that. So blocking of that is one of the important aspects under the emergency control. Then fast HVDC power transfer control. So this is another mechanism. If we have HVDC links connected to the transmission grids, so there should be an appropriate control mechanism connected to the HVDC links, which has to be taken care. Otherwise, the high voltage, what the power equipment, power controllers at the sending end, at the receiving end, at the control side, do suffer due to this. So there must be an appropriate care taken around that HVDC link, which definitely makes the things under the control, else it's a very disastrous phenomena or disastrous situation, which will be a very costlier in the due course of time. So therefore, as HVDC, the word says, lot of involvement of components, power electronic controller, circuitry, control mechanism, all are integrated into a setup to make the appropriate operation of the power system. Once the system gets affected, if there is no perfect isolation and control over that, it will override on the system only. Therefore, it must be appropriately managed. Then I was just interacting in the last class application of braking resistors. These braking resistors are the large resistors that kept in the generating stations or generating area, as and when the generator needs to be stopped, braked, and reduced to lower generation and stop it. That time, the massive generation what the generator has taken up, or the acceleration that a generator and generator and the turbine has picked up due to the automatic controlling around that generation setup, which has made the generator to run at runaway speed, which is very dangerous phenomena. We call it as a flyaway. The rotating mechanism, which with a high mass and high centrifugal forces will make them to fly away from the rotating mechanism. Therefore, they need to be appropriately cut into. Then braking resistors are the one hooked across the armature of the synchronous generator to bring that entire excess power and power which is floating dump to the earth, so that these resistors will facilitate to break the generator terminal into ground, so that generator comes to a halt very fast. Hence the name braking resistor. Definitely these resistors have to be maintained other sides. Because of the high inrush of current, they do get heated up very rapidly. There should be a proper maintenance in and around those resistor banks, etc. as an approach. Next, we were on the move to interact with the control problem. With the time play, how that power system control is sensitive with respect to time flight. When I say a particular operation, and a table over here which tell us operation and control action on a certain identity, then time period in which that action has to come into picture, else an appropriate action has to be initiated to bring the system under control, else system will not be there for your visualization. The first is relaying execution control, system voltage control. These are the two control actions in the power system operation for the good and reliable mode of operation. So this operation should be in a time stamp in a multi-second. Second to multi-second, this activity has to be executed, else the overrun of this or undue non-operation of these things will lead to disaster and may damage the other side connected component, get deteriorated or damaged. So this operation has to be such a way sequenced in the operational aspects of the power system within the second and multi-second. System frequency control and tie line power control. System frequency control in the sense the control of the frequency of that particular generating area. Suppose if I say corporation A. A is a corporation having several generators connected to load to deliver the power at specified specification. As well, that system is selling the power to the corporation B, which is a neighbor or a neighbor state, you can imagine. Then to deliver the power to the neighbor state or a neighbor corporation, it will set up transmission mechanisms. We call those things as tie lines. Tie lines are transmission lines connected between two corporations for the transaction, which is called as a power trading. To sell the power, to purchase the power, a facility is made among the corporations. So, when you are selling or trading the power through the transmission line called as a tie line, definitely the frequency becomes very sensitive factor. If you can imagine a situation, Tamil Nadu and Karnataka are the two examples, state A, state B, A and B. From the Karnataka, you are transmitting power to the Tamil Nadu, you can just imagine. Tamil Nadu State Energy Corporation is perfectly all right, but there is a deficit of energy generation, hence they are borrowing power from Karnataka State, just imagine. Therefore, there could be an imagination that transmission lines are there from Karnataka State to Tamil Nadu State to inject the power into their grid. Then the system was very healthy before the drawal of power from the Karnataka State. Assume that there was a fault, there was a disturbance in the Karnataka State transmission grid. Then this frequency deviations or a system frequency which was supposed to be at 50 Hz plus or minus, which is not within the range. This pulsation, this change in frequency not only affects Karnataka State grid, as well the power which is being pumped towards the Tamil Nadu grid, for which they are purchasing the power for their need, also gets injected with the faulty. Therefore, that frequency deviation propagates to the healthy system, which is the borrower. So their system also gets affected because of the deviation in the frequency. This is called as system frequency control, timeline power control. So when you are injecting power into their grid to deliver their required active and reactive power, the frequency is also very sensitive factor for their system operation, because they might be having their own control to manage the frequency, to manage a certain bus voltage, and to reroute the power, etc. Their control mechanism, switch gears, gets affected by the pursuit of these deviations or errors into their healthy system. Hence, such an activity must be controlled within a few seconds to few minutes. Else, this is an injection of fault into the healthy system. When a healthy system may get affected with this faulty when it becomes connected to. Because it's a parallel system. Once we inject the power to the second grid, it becomes a parallel operation. So there will be a natural chance that the other system also gets affected to a good extent. It has to be addressed within few seconds to few minutes. Now imagine this kind of few seconds to few minutes kind of control. Is it possible by a human being? Absolutely not possible. There must be a computer control. There must be a mechanism which is associated with the intelligent devices, which is only the possibility to manage this one grid or grid concept, whatever we are speaking about. Similarly, another important control aspect, economic dispatch. We are very much aware that economy related to generation, dispatch, delivery to the end user is very sensitive, and it is a very important term related to operation of the power system. It's true because irreversible nature of the fuel. The fuel, once it is being used, maybe a hydro, maybe a coal or a oil, gas, whatever so, it's very costly. Once it is burned to get into electrical energy, its calorific value cannot be the same once it comes out of the system. Therefore, once it is burned, it should be encased at the other side. This kind of irreversible nature of the fuel makes us thinking that what we generate must be adequate. What we generate must be utilized. What we generate must be dispatched and taken into monetary aspects of such an activity, which generator to generate, which one not, which next, like that. Thinking of economy concerned to the operational aspects of generation, scheduling and dispatching to the route is to be worked out within few minutes to few hours. If I unduly ignore this, just imagine a situation, you are simply burning the fuel at the generating station. If you are not able to make out this transaction useful to the end user and not making money out of that for the corporation, definitely the energy generation corporation will be in bankrupt. Therefore, it must be addressed very systematically and scientifically within a few minutes to few hours. The next important parameter, fourth, is system security analysis. As we were interacting in the earlier discussion itself, security of the system is very important factor. Whether system is a small, medium, large by its capacity, doesn't matter. How secured is that system to endure its service to the requirement matter the most. How accurately, systematically, making use of the infrastructure to meet the end user requirements without getting affected by the system turbulences, faults, problems, increment, decrement, rejection, etc. from load perspective, system is intact in nature, being able to serve today, tomorrow, and other day also. Such an evaluation, securedness, and an feature, an expectation on the system which is already put in practice to be able to overcome, be sturdy enough to sustain even after having experienced the fault, able to make all such transactions possible for the corporation. Now, I would like to speak something about this. This is an expectation. When it is an expectation, is the me or it's the you or someone operating the power system, it is the competency of the energy dispatcher who only can make best out of the things possible. If I am a best operator, I can definitely make best out of the possibilities to make the energy system corporation profitable. If I am out of my interest, simply making my operation, let it go, let it run. Definitely, I am not extracting best out of that. I am just making my normal operation. It is not going to benefit the corporation. Maybe I am just making natural resources or nation resources just wasted. Therefore, it must be secured appropriately. It must be installed such that it will be there for your service in the future days also. For this, there are so many aspects to be monitored, controlled, worked out, such that security is always kept in mind whenever a decision is taken into consideration. So it has to be in a few minutes to few hours. So it is a very serious aspect. Lot of monetary investment has been put into the real world. It has to be addressed. The another important aspect from the control viewpoint is unit commitment. As it is a commitment of certain generator in a certain generating plant planned to serve for a certain megawatt and later in pair with the other, which has to be planned systematically well in advance before it is really in practice to connect. It has to be worked out. As we have discussed in the earlier interaction, unit commitment is the commitment of the selected generator to combine and develop certain megawatts for the requirement, being most economical in operation for a range of generation from minimum to maximum, making use of minimum resources and meeting the requirements effectively. Such a combination has to be worked out. The other way of it is shut down. When I want to take out, as per the load decline, load is falling down. It is not intelligent to run all the generator all the time. Certain generators need to be withdrawn so that remaining generations meet the requirement. When I remove, which one to remove first? Which one the second? When I want to add, which one to first, which one second? All such commitments, such addition, deletion from the schedule has to be properly planned. That as a unit come under the unit, as an economy is come under economic dispatch. So therefore, it is a few hours to few weeks. You can see the duration because commitment is nothing but today it is committed. How long it will be? It will be in pair. It will be in pair for hours to days to week to the month. Hence, it must be such that minimum hours to week your decision must be taken appropriately so that such an agreement makes the control very proper. And maintenance scheduling. As we are very clear, every connected equipment or a component in the system is integration. It is an integration of all such together. As the periodicity, as the run hours come down, each equipment on its own pattern of design requires overhauling, maintenance, observation, recalibration, reinstallation, something like that. So for that, maintenance activity, to view its appropriateness right now, to see to it that it performs similar in the next days to come. So I should have, according to the equipment, plan a schedule such that periodic maintenance, monthly or quarterly or half yearly, like that, according to the types of equipment which we are trying to categorize and we are trying to manage and adhere this schedule, so that such schedule ensures reliable operation of the system. So it can be 1 month to 1 year, like a time stamping you can plan. System plan. This is a very interesting factor connected to your energy corporation. Once a party is invested in generation, transmission, distribution, whichever segments they fall into, the system right now, which is installed with the capacity and possible constraints, may be well and very adequate. It is not the same for the next years to come. Over a period of time, due to the growth of loads, typical types of loads connected to your system demand typical delivery. Then, as the load growth occurs, existing system may not be able to cope up with the fullest capacity what it can deliver. Then, system planning has to be there as an designing activity, future planning activity for the energy corporation to be in the market. Now, today you will see power trading is a business. It is as you are very clearly known, Deregulation Act of India Energy Sector 2002 and revision in 2003. It is anybody can generate, anybody can sell, whomever you want you can sell, provided you maintain the specification as put as guidelines. In that due regard, to be in the market, to be in the sector, I must be able to anticipate, plan, predict, work out, invest, and attract the customer from the load perspective so that they will not run away from me. They are able to get connected to me, they keep on being served from my energy system. Then it is possible if my system is reliable, my system is able to cope up their requirement effectively, then my system for the next 1 year, next 5 years, able to even feed their requirement even after load growth is noticed. It has to be planned by the corporation scientifically. It may be 1 year to 10 years. These are the small, it is a small table, few of the aspects which the power control mechanisms with the time stamp is mentioned. The similar things I have mentioned in the word, the system must have adequate capacity to meet continuously changing active and reactive power demand. This is a dynamic behavior. Because of the load growth or load changes, the system must be capable of working out such an stringent changes in the demand has to be worked out, keeping proper spinning reserve. As I was interacting in the earlier class, spinning reserve is a spare energy that the generators together, when I sum up Pg1 plus Pg2 plus Pg3 and last, minus the load, minus the losses, remain as a residue. That kind of megawatt, which is called as a spinning energy, which is a ready-to-go energy, which is able to supplement stringent changes in the load or sudden drop in the generation, sudden change in the schedule. That floating energy is ready to meet the contingent changes. That kind of energy has to be planned very appropriately. If such an energy is readily in abundance, which will postpone future installation of any generator. Maybe a due course of time you are planning to have one more generator. If your spinning energy is sufficient, it can postpone one more investment, which is you can postpone your generation or installation for a few years later. Or if it is so short, definitely your system will be under the difficulty. Deficit generation will demand you either to install a generation setup or borrow from the neighbor corporation and feed your requirement. This way, a spinning reserve energy will play on your operation. Then, system should be designed and operated so as to supply electrical energy at minimum cost with the minimum adverse ecological impact. This is one of the important aspects as nowadays you will find the global warming, the fauna and flora getting affected, maybe the hydro or maybe the nuclear based generation or thermal based generation. Just see, one side we are benefited by electricity for the country's growth, index of economy, the other side ecological imbalance or impact harming the life of the living habitat, shifting their habitat to other sites. This is another adverse effect. It must be such a way viewed, engineering point of view, we must see to that the product of, the total production cost and energy investment such that it is minimum for the investor, minimum for the purchaser, and it will not affect that kind of ecology, which is nature's gift, which should be there for the good health of everybody and for the nature is considered. The next point which we would like to see is electrical power supplied to the consumer must meet certain minimum quality standards with respect to frequency, voltage magnitude, and meet desired level of reliability. So you can just see all the way when I say a power quality, electrical power quality what we deliver should be such that it is able to meet the end user satisfaction level with respect to the quantity of power it is demanded. You are able to provide fullest capacity of its demand and able to maintain the continuity to the load which they will not suffer, and you are not having any sudden changes, fluctuations, drop, dip, such that with respect to frequency and voltage. Because those two are the important parameters affect and cause the industries to struggle, motors, generator, transformer, other connected system to excess or exceed their losses which they are already incurring, and it will cause additional damage to the system. So it must be seen that it will not affect in that due regard. So the quality of the power must be ensured. The next parameter, it should maintain scheduled silent flow and contractual power exchange. This parameter comes in picture whenever a corporation A like a Karnataka and a corporation B like a Tamil Nadu, they are exchanging the power. It must be scheduled such that your agreements are fulfilled all the time, because there is a clause and anti-clause like concept. When I go to the next aspect, energy control center, there comes the generation setups will agree upon themselves what the generation they do excess will be sold to other, or which they are purchasing will be depending upon the quality of the power which the other is selling. We say it as a wheeling of power, floating of power, interconnected operation. There comes the contractual energy what it is bid, which is accepted by the both the parties to supply and absorb. They must adhere to their guidelines. Once they are not able to supply, anti-clause, the penalty on them is paid. Once it is able to supply, the charges for the usage of the transmission mechanism, charges for the energy billing has to be paid to the parties which is supplied. Like contractual power exchange, silent flow, scheduling has to be maintained so that it is possible. It is possible if our system is adhering all these control parameters in an effective manner. The another component which we see is various control problems or areas, control areas in the power system. We find the basic requirement is modeling of power system components, understand how generator is represented, how transformer is represented, transmission lines are represented, loads are represented for the analysis point of view to see to it that its effectiveness before it is really put in practice. For this, I call upon the simulation software. Simulation software facilitates us to visualize the reality of the power system before it is really put in service. So, representation of all the electrical components to the truthfulness of their functionality. A generator, an ideal voltage source behind an impedance, an ideal current source across an admittance. Like that, representation of generator has to happen. How a transformer with a 3 winding, transformer with a tap changer facility has to be represented. Then transmission line with either impedance notation or admittance notation is represented for the kilometers of its length. Then interconnection of bus to another in the form of either impedance matrix of the system or admittance matrix of the system we are able to represent. And the loads are modeled as a constant admittances or impedances in that regard. So all those parameters, unless and until I have a concrete idea of how to represent into the software, how to interconnect them in the environment presented to us, and in fact, certain changes, stringent variations, and analyze the effect of that on generation, effect of that on transmission line, and you will see to that this is the area which is prone to get affected, which is the area there is a scope to improve, which is the area there is a scope to expand and future development. That can be realized and understood by modeling the power system components effectively, analyzing it in an engineering perspective, having drawn the conclusions from that, makes a knowledgeable value for the power system in operation. This is one of the interesting aspects of power engineer in the real world. So they are having lot of such software, legal software, which will be used to simulate and analyze its effectiveness before it is really put into market. See to the impact of this simulation software. They must be run before really put in real practice, because installation of a generating setup, installation of a substation, drawing the line from generating area to substation, it requires a lot of time. It requires a lot of catchment of area and investment and all other legalities associated with the requirement. For that, lot of investment has to happen. Before it is really put into the real investment, it needs to be realized first. How it is going to sustain and how it is going to perform. So this is how the representation analysis has to be done in a scientific manner. Next, the other control area or problem in the power system is economic operation power system. This has to be seen very effectively and we need commitment associated with that. So these are two parameters just we have discussed. Economy related to generation, making use of resources, delivering the required megawatt to the grid, to the end user, how this is going to fulfill the requirement and how it is going to pay back to you, so that your energy corporation in this trading is always a profitable one and able to cope up with the contingent demands or variation of the system as a load perspective. So it must be viewed and evaluated well in advance. Similarly, the unit commitment, you have to evaluate in a generating station. If you have 10 generators, among the 10, which are all the selected generators, you want to title them under the commitment schedule. Just by the normal running or base load generators. The titled one, identified, tagged one, have to be in a schedule commitment. They must be responding to your requirement automatically to the energy control centers respond or to the command like that. So that such an activity is economical to the corporation. Then hydrothermal coordination. This parameter comes whenever we have thermal generation. When you have a thermal generation either by coal or gas or oil, definitely huge water is required for that. As we know, ultimately when you burn the fuel, it is the water we get into steam, and that is the steam running the turbines, and a huge amount of water is required. To run the thermal plant, just imagine how much of the water you require for that. Then imagine you are connecting that thermal plant with a hydro station nearby, and you are operating these two together called as hydrothermal coordination. You are meeting the demand by two aspects. One is thermal setup, which is using a lot of resource as well as water for its own type of generation and meet the requirement. As well, separately another identity, hydro generation. When you have a hydro generation truly running on natural resources, catchment area and all, when that generation through hydro, generation through thermal are connected by a grid and delivering the load, we call it as a hydrothermal coordination. How do you make adjustments, command, control on thermal side and to the hydro side, so that load is addressed very appropriately, economically, looking to the consideration like availability of the water at the hydro catchment, availability of the coal at the coal ash, and requirement of particular set point, maintenance, and all other material resources which are involved in hydrothermal have to be economically planned. We have learned something called as hydrothermal coordination by penalty sector, alpha gamma method. We will see in the next module. So this kind of integration of hydro generation setup with the thermal generation setup together to meet a certain grid demand or a load, how that coordination among them is brought into. We have a very good study under this heading. Next comes automatic generation control. Here starts a computer control of generation. AGC is nothing but automatic generation control. It is a computer control of generation and delivery to the requirement. How is that? Synchronous generator is monitored, controlled, so that such a generation meets the requirement very effectively, and that control setup always keep an automatic voltage monitoring. We call it as the automatic voltage regulator, AVR. monitoring the voltage, irrespective whether there is a load or no load of the station, how that terminal voltage is maintained appropriately by excitation control, and other side from the turbine, how that fuel input to the turbine is managed to see to it that RPM of the turbine is managed such that frequency is maintained constant. It means automatic generation control in broad term is, it is the computer control of generation and delivery such that internally it is monitoring two aspects. One is maintaining the terminal voltage constant by automatic voltage regulator control. The another is automatic load frequency control. As the load changes, it is natural to see to that dip in the frequency. How is that dip in the frequency is controlled automatically by changing the input fuel to the turbine is managed together by two separate control loops. That is done under the heading automatic generation control. So automatic generation control in the broad term is just a control of energy system such that a 10 active and reactive power megawatt generator is able to meet the requirement effectively, keeping the frequency and the terminal voltage constant. So this is separately addressed in another module in the coming days. Then AGC for interconnected operation system. It means to say, when I can say automatic generation control inside a generating plant. Let's say there are 10 generators. All the 10 generators are computer controlled from a small computer room inside that station. That computer controls all the 10 generators. It monitors the health of all the 10 generators. It will recognize what is the condition of the generator 1 after having instrumented properly. Temperature, speed, voltage, current, frequency, all the parameters connected to generator number 1, generator number 2, 3, 4, 5, 10. All the data is available at the energy center of that, called as computer control of that. Then that is monitoring a single station. If I view a single station, such a station making interconnected operation, just imagine, there is a neighbor, another such generating station having such an infrastructure monitoring its own generator, and these two AGCs, automatic generation control A, automatic generation control B, want to exchange the power, trade the power, then it is interconnected operation. When it is interconnected operation, it calls for someone to monitor it. How that AGC A, AGC B will remember what they have supplied, who has borrowed, how long they have borrowed, what is that they have borrowed. So it has to be monitored. Then it calls for someone called as third party. So it is called again AGC for interconnected operation. Now I am making myself among the corporation. Corporation A, its own AGC. Corporation B, its own AGC. C, D, E, F. Centrally there is another agency which is called Central Controlling Unit, which is a central agency. To him all the corporations are agreed upon. It is an agreement, it is a separate energy setup, energy control room, which will keep monitoring setup A, setup B, setup C, D, E, like that. All together energy monitoring is done separately, and that is called head office. From that bidding occurs. Who want to sell the power, who want to borrow the power, who, how long, through what path they want to borrow. In that due regard, third party is necessary to make this agreement witnessed, monitored and controlled. In that direction again, a top layer kind of AGC, which is called as automatic generation controller for interconnected operation. You can just imagine so many colleges being operated of their own local control, and a university ride on their guidelines and whatever the regulations, like that. So it's an AGC, interconnected means central, and AGC in the state is local operation, and guidelines and regulations come from them, monitoring and making the directions which become central. Like that, AGC, automatic generation control, is very necessary for interconnected operations also, because somebody has to monitor, bill, transact and make the thing certified. In that due regard, AGC is meant, discussed, elevated in fashion for interconnected operations. Then another important area of interaction is voltage and reactive power control. Yes, my friend, when it is a power system, the beauty of this power system is the interconnection between the P and the delta. The active power and frequency, reactive power voltage has a great interdependency in the power system operation. If we are really cautious, any variation in the frequency, if it is noticed, it is an indicator that there is an active power mismatch in the system, and if there is a flicker or a drop or a dip in the voltage, it is an indicator that system is suffering with a deficit of reactive power. If we are able to monitor these things, system operation becomes quite comfortable. Therefore, voltage and reactive power control has to be very systematic. Otherwise, there is a keyword called as voltage instability. Is an ability not maintaining the terminal voltage as stipulated due to the sudden changes, impacts, faults, etc. Is an inability I speak, which will lead to voltage collapse. Voltage collapse is a serious drop of voltage as a load growth occurs. If there is a change in load tremendously in a step manner, that step manner of load, if it is not coped up by the generating system, it will affect very badly the voltage profile. We will learn this in another chapter. Voltage collapse is a very serious phenomena. As the load growth occurs on the system, it will actively hit active and reactive power demands. If the system is not able to respond in a similar fashion, the voltage collapse, a relation between the incremental change in megawatt and megavolt and ampere reactive, the fall of voltage is plotted as a curve. That curve shows a tremendous fall of voltage as an increment of a minor active and reactive power. So therefore, control of them is very crucial and important. Then another key keyword again striked back here is power system security. So securedness of each of the components cumulatively adds to the total string security over here. Every component from the generating point of view to the distribution point of view, if you see how secured each one of them, if I consider the entire connected security, its reliability can be spoken. So it is to ensure the component of that standard, component of that capacity, component of that deserving ability to respond to your requirement has to be incorporated such that it is an power system's entire system security is to be measured. For that, I was just given you a hint. It is not simply by definition. It should be with the suitable algorithms, monitoring parameters, assessing the state of those parameters for their response. So if I am able to monitor them, then I am able to ensure what is my state right now. What will be the state in the next 1 hour? What will be the state in the next 4 hours, 5 hours, like that if the similar load growth increases, similar load growth falls? What is the securedness of the system? I must be able to anticipate. If I am not doing it, my friends, the corporation is going to suffer a lot. This is how the engineering aspect with the commerce has to be integrated into the analysis. Therefore, it is a security which is electrical perspective, and associated with it is commerce, where a huge money is invested by the corporation. So much of connections, interconnection, men, material resources were utilized over here. Then load forecasting techniques. Yes. Once the power system is integrated with a suitable number of generators, transmission mechanism, all such requirements together in the reality, if I am not predicting the load growth on the station in the due years to come or due months to come, and my set point which my one of the engineer has set and locked it, it is running perfectly now and the load is increasing gradually. If I am not able to change the set point properly, it's of no use. Or if I am not able to predict properly for the capacity that I have installed. I have installed a capacity, today it is a 50 megawatt requirement. I have installed a generator of 100 megawatt capacity. 50 megawatt is a spare for me. When do I encash this 50 megawatt additional generation which is there with me? Then it is again forecasting of load. What will be the upcoming day's load on my station? How do I make this load met so that such an generation arrangement in my corporation become profitable to me, like that. I should be able to predict, anticipate, and able to project my requirement so that it is going to make me profit to the corporation. So load forecasting is prediction of next and upcoming days load variation so that my corporation is ready to go with those variations, so that such an readiness ensures me the profit to the corporation. This load forecasting is one of the important background activity in the energy control sector. So it must be there. And state estimation. State estimation is one of the technical measures. Having measured some of the electrical parameters, I am able to evaluate total state of health of power system, current state of power system, probable changes what the state would encounter in the due course of changes in the load. I am able to monitor. To come back to this point, state estimation is a process. I cannot measure all the parameters at all the buses of geography of a power system. Entire Karnataka, if you imagine a power system, there are so many transmission section buses if I call. For me, it becomes cumbersome to measure voltage at all the points, current at all the points, voltage at all the points, power at all the points, frequency at all the points, condition at all the points. It's a cumbersome and impossible task. Then what is being done in the state estimation is critical state variable, the parameter which really influence, which are of your dependent control, are the only parameter monitored. Develop an algorithm using those parameters measured at selected points of your power system. Not at all, only at selected buses of your power system. Install your equipment, measure the selected state variable. State variable may be voltage, current, power, reactive power, or it may be angle. These are the state variables. So these state variable minimum by number you measure. You telemeter to the energy control center. Develop a computer algorithm. Using those minimum values measured, you put in program and try to evaluate its best possible value in the due course of changes. Next course of change. Then see to it that whether your system is able to cope up with those probable variations if in the near future. And this kind of estimation of state of power system with the minimum state variable, we call it as state estimation. State estimation is a process of evaluation of state variable for their best fit value and to evaluate approximate load flow study, approximate real security analysis, and approximate study of that what will be the reflection of this system if at all such an event or such an incident occur on the real time. This kind of engineering estimation is being done. SCADA, Supervisory Control and Data Activation System. So I am coming to the need of a software and a hardware for the energy dispatcher to monitor it. This is one of the infrastructure put in an energy control center. Now I come to a scenario. Energy control center is a computer room, a large computer room in which number of computers are installed and all the computers are hierarchically controlled, or login user, supervisor, manager, and the center chief. Like that, hierarchically computers are managed like a banking software. A manager, an accountant, cashier, and a developer, and another finance advisor, like that. Systematically, hierarchically, logins are provided. That software with all kind of mechanism able to provide real-time view of power system. Is the graphical user interface facilitated on the computer screen with a large screen on the wall or on the around, which will facilitate you to view the real power system on the real ground. And we can see what is the generation, what kind of loads are connected, how is the power flow, what is the voltage, what is the frequency at this point. All these kinds of things are visualized on the screen. This is computer control, correct? supervisory control and data acquisition for the energy control. You will see its feature very soon. Then trends in power system operation control. This is the latest feature. This is a feature of the current trend. How is that? Behavioral things of the power system, its business, its scope, its parameters are changing in the current requirement. All such latest trends and events happening in and around the power system, around the globe has to be discussed so that such a knowledge, such an event, if at all useful, I should update into my knowledge database. This is called trends in power system operation control. This is the latest layer. New researches are going on, new methodologies are coming up, new equipment control algorithms, which different way of thinking of control of power system for its betterment has to be taken into consideration. So all these are the areas where we have a scope for power system operation. Then we have